All right, let's talk about chemistry. It's literally everywhere. The inventions that have saved millions of lives, the stuff that's built our entire modern world. But what if those same amazing inventions are also silently harming our planet? It's a huge question. And today we're diving into a really cool, revolutionary idea called green chemistry, which is all about tackling that problem right from the get go. Seriously, just think about that for a second. What if the medicines we take, the plastics we use, the fuels we burn, what if they could just do their job and then, poof, just disappear without leaving any harmful mess behind? That's not science fiction. That's the core question, the driving force behind this whole field of green chemistry. Okay, so to really get why we even need this new approach, we've got to look back. We have to understand the good, the bad, and the ugly of traditional chemistry. The incredible wins, but also the hidden price tag that came with them. And look, there's absolutely no denying it. Chemistry has been a miracle worker for humanity. I mean, it's given us life-saving things like antibiotics and vaccines, but also the fabrics we wear, the computer chips in our phones, you name it. It has completely changed human life for the better in 1,000 different ways. But, and there is always a but, right? All that amazing progress came with a pretty big trade-off. For a long, long time, the main goal was just make the thing, make it work, make it cheap. The waste, the pollution, the long-term side effects, that was often seen as a problem for later, someone else's problem. A perfect example of this is the story of DDT. On the one hand, this stuff was a miracle. No joke. It saved millions of lives by killing off the mosquitoes that carry malaria. A huge win for humanity. But then, we discovered the hidden cost. DDT just doesn't go away. It sticks around in the environment, builds up in the fat of animals, and gets more and more toxic as it goes up the food chain, just devastating wildlife. It was an amazing tool, but it was also a poison that wouldn't quit. And it's stories exactly like that one that forced a totally new way of thinking. It sparked a new philosophy, one that asks a really simple but powerful question. What if we could design our chemistry to avoid these problems from the very start? And that right there is the core idea. It was championed by a guy named Paul Anastas, who's known as the father of green chemistry. The whole philosophy is actually pretty simple, but it's also incredibly profound. It's this: stop focusing on cleaning up pollution after the fact. Instead, don't create it in the first place. It's a massive shift from reacting to a mess to preventing the mess altogether. It's all about designing smarter, right from square one. So how does this actually work in the real world? Well, green chemistry isn't just a vague idea. It's built on 12 solid guiding principles. You can think of them like a recipe, or maybe a toolkit for chemists to invent things that are better for us and for the planet. We're not going to go through all 12, but let's break down a few of the really key ones. All right, number one, and this is the big one: prevention. This is the foundation of the entire philosophy. I mean, it sounds almost too simple, doesn't it? It's better to prevent waste than to clean it up. Duh. But it's actually a huge mental shift. Instead of spending a fortune on cleanup and waste disposal, you design your chemical process so there's barely any waste to deal with in the first place. So how do you prevent waste? Well, a major way is through this next principle, called atom economy. Think of it like a super efficient recipe. The goal is to make sure every single atom from your ingredients, your starting materials, actually ends up in the final cake, the product you want. No leftover flour, no extra eggshells, nothing is wasted. And this is a really important point. In old school chemistry, you might have a high yield. That means you got a lot of the product you wanted. Great. But if that same process also created a giant pile of useless, hazardous gunk, well, your atom economy is terrible. Green chemistry says it's not just about getting a lot of product. It's about being incredibly efficient. It's about turning all your ingredients into the final cake with basically zero scraps left on the counter. The goal here is to get as close to 100% efficiency as you possibly can. You want every single thing you put in the pot to come out as the thing you're trying to make. And this isn't just about being neat and tidy. Less waste means less pollution, it means lower costs for companies, and honestly, it's just a more elegant, smarter way to do chemistry. Okay, this next principle is another game changer. It's not just about making the process of creating something cleaner, it's about making the final thing itself safer. The idea is to intentionally design molecules that are great at what they do, but are also way less toxic to people and the environment. Let's go back to that DDT story to see how this works. As soon as we realized how dangerous DDT was,
chemists went back to the drawing board. They came up with new insecticides, like BHC, that were designed from the ground up not just to be effective against pests, but also to break down easily and be less harmful to everything else. That is designing safer chemicals in action.
Okay, so that's a little bit of the theory behind it, but what does this stuff actually look like out in the real world? Well, let's take a look at a problem that I think we can all relate to. Yeah, we all know this one, plastic. It's an amazing, super useful material, but most of it was designed to last forever. And when we're done with it, where does it go? It just sits there, in our landfills and our oceans for centuries. It's the poster child for a product designed without any thought for what happens at the end of its life. But this is where green chemistry comes in with a really clever solution: biodegradable polymers. So instead of making these super strong, unbreakable plastic chains, scientists are now designing plastics with built-in weak spots. These links are a lot like the ones you find in natural stuff, like leaves or wood. And those weak spots basically act like a giant eat here sign for microbes in the soil, which lets them come in and just break the plastic down. It's an amazing example of designing for a product's entire life cycle, from the moment it's made to the moment it disappears. And this really brings us to the bigger picture here. Because green chemistry isn't just about making smarter plastics or safer pesticides. It's way bigger than that. It's a fundamental tool for building a genuinely sustainable future for all of us. You hear that term sustainable development thrown around a lot, right? It just means meeting our needs today without messing things up for future generations. Well, green chemistry is one of the most powerful engines we have to actually do that. It gives us a blueprint for how to keep innovating, how to keep creating cool new things, but to do it in a way that works with our planet, not against it. And that's what makes this whole idea so powerful. We're not working with new elements. We've got the same periodic table we've always had. Carbon is still carbon. Oxygen is still oxygen. What's changed is the thinking. It's our approach, our creativity, and maybe most importantly, our sense of responsibility for what we invent. Ultimately, that's what green chemistry is all about. It's about making better choices. It's a roadmap that allows chemists and engineers to invent a world that's not just innovative and prosperous, but also safe and sustainable. And so the real question it leaves for every single one of us is this: now that we know how to do this, now that we know how to invent more wisely, what kind of future are we going to choose to build?